Okay, so in this video we're going to look at problem number 3 and 4 on our sample final. It states, write down an equation of the tangent line to the graph of y equals 1 plus 2e to the x at the point where x is equal to 0. And then in problem number 4 we're going to have to determine the slope of the tangent line to the graph of the equation 5x squared plus 3y squared plus xy equals 15 at the point negative 1, 2. So let's begin with number 3. So in problem number 3, you can solve this in a 4-step process. Basically what you want to do is the following. Because we have to write down the equation of a tangent line to the graph of this particular function at the given point, we're first going to need to find, in this case, y prime. After you find y prime, you're going to plug in 0 into your derivative. So remember, m is equal to y prime at your given value of x. I'll label this as x1, where again x1 will be basically the given value of x. After you find your slope of your tangent line, you're then going to find the associated y coordinate for your given x value. So what we have here is that y1 is basically going to equal to y of x1, which basically means I plug in the given value of x into my equation, and then I use this nice point slope formula, which basically says that y minus y1 is equal to m times x minus x1 to write my equation of the tangent line. So here goes. Well, let's find the derivative of y. If we find the derivative of y, we're going to get that y prime is going to equal to, well, derivative of 1 is 0. The derivative of 2e to the x is going to be 2e to the x, since the derivative of e to the x is itself. But because I have a 2 in front of it, then it's just 2e to the x. Now, I'm going to find my slope. Well, to find my slope, I plug in the given value of x into our derivative. So m is going to equal to y prime at x equals 0. Well, you're going to get the following. It's 2e to the 0. And now just notice that if you have e to the 0, some number raised to the 0 power is always going to be 1. So we have 2 times 1, which is 2. Now, you can find the given value of your y coordinate. Just plug in x back into your equation. So what we have is y at x equals 0 is going to be equal to 1 plus 2e to the 0. This will give us 1 plus 2, since 2e to the 0 is 2. And 1 plus 2 is 3. So we have our y coordinate, right? I'm just going to label it as y1. Y1 is 3, our slope is 2, our given x value was 0. So therefore, we have this equation. Y minus y1 equals m times x minus x1. Just plug in your values and rewrite it in terms of your slope-intercept form. So what we have is y minus 3 equals 2 times x minus 0. Now if you were to rewrite this, you're going to have y minus 3 equals distribute your x, distribute your slope. You have 2x minus 0, 2x minus 0. And now just add 3 on both sides, and that will give you your final answer. So what you'll see is that your slope, your equation of your tangent line is going to be y equals 2x plus 3. How did I get the 3? I just simply add 3 to both sides. And that's it. That will be your final answer. Y equals 2x plus 3. Alright, on to problem number 4. Problem number 4, we're going to have to use implicit differentiation. So first, you're going to have to find dy dx. Then, if you want to get just the slope of the tangent line, you'll have to plug in your given coordinates for x and y into your derivative, which is your slope. So then, we say that m is equal to dy dx at the given point, which is your x comma y. So it's going to be -1, 2. So if you want to find dy dx, you know that for this equation, when you apply implicit differentiation, the first step is to take the derivative with respect to x. So, let's begin. Well, the derivative of 5x squared with respect to x, that's going to be 10x. Take the derivative of 3y squared with respect to x, you're going to get 6y dy dx. Right? Remember, every time your variables don't match, when you apply implicit differentiation, you're taking the derivative of that variable with respect to x. So here we're going to have dy dx. Now if you take the derivative of x times y, you're going to have to apply the product rule. So if we apply the product rule here, keep x, take the derivative of y, that will give you x dy dx. Keep y, and take the derivative of x, that's going to be 1. So you have y times 1, which is just y. And now finally, you take the derivative of 15, which is 0. Since the derivative of any constant is 0. Now what I want to do is just rewrite this a little bit, try my best to isolate dy dx, and then I'll be able to plug in, my given point, -1, 2, to find the slope. So we're going to have 10x plus 6y dy dx. Now, x times dy dx, that's just x dy dx. And the derivative of, if I take y times 1, that's just y, equals to 0. So now, all my terms that do not have a dy dx, such as 10x and y, I can move them to the other side of the equation. So that will give me the following. On this left-hand side, I'm going to have 6y dy dx plus x dy dx equals to -10x minus y, right? If I want to move 10x and positive y on the other side of the equation, I have to subtract them. Therefore, they're going to be negative on the right-hand side of my equation. Now what I want to do is get dy dx by itself. So I can factor dy dx, and then the remaining terms, which will be 6y plus x, I can divide it on both sides of the equation, and that will give me the following. So I'm basically going to do 2 steps in one here, only because of the fact that I'm running out of room. We're going to have dy dx equals -10x minus y over 6y plus x. And that is my derivative. So since I found my derivative now, dy dx, I can now find the slope. If I want to find the slope, m, I just have to plug in my given point into our derivative. So, I'll do it over here. M is going to equal to dy dx at the point -1, 2. So wherever I see x, I replace it with -1. Wherever I see wherever I see a y, I replace it with a 2. So what we'll get is the following. We'll have -10 times -1 minus 2 over 6 times 2 plus 1. And now I'm just going to simplify this. -10 times -1 is 10. 10 minus 2 is 8. over 6 times 2 plus 1, that's 12 plus 1, which is 13. So that would be my slope of my tangent line, 8 over 13. And that completes problem number 4.